Did you know that one missing environment variable can crash your entire Kubernetes cluster or production pipeline? And it happens every day. Hello everyone, I am Nikhil Kumar. Welcome back to the channel. Today we are mastering the silent engine of Linux, that is environment variable. If you get these wrong, application refuse to start, Docker container crash instantly, and CI/CD pipeline fail mysteriously. We are going to move beyond just typing export. We will understand the runtime configuration, the concept used by Netflix, Google, and every DevOps engineer to manage application at scale. So let's record how Linux actually thinks. So before running any command, let's understand what are environment variables. An environment variable is simply a key value pair that lives in the shell environment. Linux and applications use environment variables to answer questions like which port should I run on, where is Java installed, where is my path, which environment is this, development or production. Environment variables are not files. They live in memory and every process inherits them. Now let's see it in the action. So to view any environment variables, Linux gives us very simple command, that is env. So if I type env, so this command print all the environment variable. So you will see many variables here. You are not expected to memorize all of them. Now let's look at some important ones. So I'm going to print a path in this particular terminal. So for that I can use echo $ and path in uppercase. In Linux, the $ tells the shell this is a variable and give me its value. So here the path itself is just a name, and $path means replace this name with the actual value stored inside this particular variable. So when I run echo $path, it will print the value of the path variable. So path is a variable, so that's why I use $ here. So if I hit enter here, so here you can see the value which is being stored inside the path variable, and this is the list of directories. This particular path tells Linux where to look for a commands. That is why we can type ls or echo directly instead of /bin/ls or /bin/echo. If I write which echo, it will give us a precise path of this particular command, and this particular path is available in the path variable. That's why we are able to run this without absolute path of the command. Now you understand how we can check the variables and how we can view the variable information as well. Now let's create our own environment variables. Let's say I want to configure an application using an environment variable. For that I'm going to create one environment variable for application port. So to create any variable, we need to use a keyword, that is export. And then we need to give a variable name. So I'm giving app_port equal to 8080. So app_port is a variable and 8080 is a value of that. So if I hit enter, the environment variable got created. Now let's verify it. So if I run echo $app_port, so I can see the value of this particular variable, and this variable exists only in this particular shell. If I open a new terminal or log out from this session, this particular variable will disappear. Let me duplicate the session and let me enter the password again. And if I run the same command, I won't be able to see the information about that particular variable because this particular environment variable lives only in this particular shell. And that's very important to understand. So how do application actually use these variable? So application doesn't care about file names. They read environment variable directly from the processes. So let's simulate this with a simple command. So here I am going to use echo command, echo : application will start on port and the variable information. So if I hit enter, so we can see the variable information got updated dynamically along with the string which we passed via echo command. And this is exactly how applications behave internally. In Node.js, Java, Python, Go, etc., the code reads environment variable at the runtime only. That's why we don't hardcode values inside the code. We use environment variable in those scenarios. Now let's understand shell level versus system level environment variable. The environment variables we created exist only in this particular shell. If I open a new terminal, it will gone. So where do we define variables permanently? So there are two common places. First is user level, and another is system level. So for user levels, Linux uses file like, if I do ls-a, so here we can see file like .bashrc. So if I open this file, so bashrc, So in this, we can specify the environment variable, and you can see export path is also updated here. And this is the declaration of the path variable. And if you see below, export is being used over there to create an environment variable. One approach is this one. I'm not going to edit them now, just understand the concept here. And for the system-wide variables, services use systemd or /etc environment file. So there is one file called /etc environment. So we can create an environment variable in this particular file as well. As you can see in this, I have already created an environment variable for the kube configuration. So whenever I need to use or pass this particular path, I can directly use this variable instead of giving a full path of it. Now we understand how we can make our environment variables permanent across the sessions. And this brings us to a runtime configuration. So runtime configuration means changing application behavior without changing any code. And environment variables are perfect for this. So same application binary, but different behavior in different environments. Like if we are working in the dev environment, so we can use debug equal to true. And if we are working with a prod, we can use debug equal to false. This is how Docker, Kubernetes or the CI/CD pipelines work. They inject environment variables at the runtime. Now let's connect this to our services. This is where things usually break in the production. So when a service starts, it doesn't start in isolation. It is started by systemd, and whatever environment systemd has, service inherit it. Think of this yellow box as an environment block. Everything inside this block is what your application sees when it starts. Now look at the service process. This is your application. It expects certain variables to exist like path, db host, db password and java home. If even one of these is missing or wrong, the service may fail to start. If there is a wrong path, then binary not found error will come up. If the java home is not there, JVM doesn't start. Database credentials are missing, app crashes immediately. This is why outages happen, not because of bad code, but because the runtime environment was wrong. And this is important. This is not a Kubernetes magic. This behavior exists even on a plain Linux server. Kubernetes, Docker, systemd, they all rely on the same Linux concept. If you understand this slide, you understand why services fail before even serving traffic. And that brings us to the end of this video. Now you know how to configure your application using variables. But there is a massive problem that happened before configuration. How do you actually get the software on the server safely? If you get the wrong version of Java or Nginx, no amount of environment variable can save your production server. That is why in the next video we are going to cover the Linux package management, where we will understand how yum and DNFs works under the hood. If you found this helpful, hit like, share it with your friends and subscribe for more content like this. Thanks for watching. I will see you in the next one.